Hey guys, Mr. Reese here, talking about Algebra 2, Section 1.4. Today we're talking about rewriting formulas and equations. We'll be manipulating formulas to get what we want. So, some manipulation going on here. You've already guys seen this slide here, difference between the expression and equation. Today we're going to be just talking about equations. So, this slide, the part on the right there. When you solve equations, what you really have to do is inverse operations. So you're getting rid of addition by using subtraction, getting rid of multiplication by using division. Every operation has its inverse operation. We'll be using that as we go through. On the left side here, you'll see the traditional equation. So, you're going through this kind of a problem, taking, hey, I got to subtract 5 off both sides, and I got to divide by 12 on both sides, and you get your answer. So that's the traditional equation. What a literal equation is, that's what we're really focused on today. Literal equation is a bunch of letters. So it's like alphabet vomit in your equation. So a lot of letters here. So if you want to get x all by itself, you have to get rid of everything else. So I'm going to take and move this by over to the other side by subtraction. Nah, almost got x all by itself, but now I got to get rid of the a. So I'll go through it and divide by a on both sides until I get my result there. X equals, so I solved for x equals c minus b y over a. So manipulating means moving things around to get what you want. In this case, you'll have these sometimes where maybe the variable that you want appears more than once. So first thing, we'll take the x and move it over to the other side. So we got x's all together. Now here's the tricky step. So you have an x and another x. And so when you have x's that appear multiple times, what you really can do is you can factor. It's called GCF, or greatest common factor. So you pull this x out. So this parentheses shows us that it's kind of the opposite of distributing. X really applies to the y and to the 1, so we factored it out, greatest common factor, and then we can go ahead and divide by that quantity y minus 1 to get our result of x equals y over y minus 1. So when x appears twice, you'll have to do some factoring. Same thing happens here, except we have fractions. So I'll show you this as we go. So fractions are the F word in math, so we want to get rid of these. So one of the things that we do that we've talked about before is we use the least common denominator. The least common denominator in this case is xy, and what will help us do is get rid of all the fractions. You notice here, if you take xy times it by a, the x's cancel, so you have ay. If you have xy and times it by b over y, the y's cancel, so you have bx. And of course, xy times the c gives us cxy. Now this generates another problem for us because now we have x that appears multiple times. That's kind of annoying. But we'll just do it like we did the previous problem. We'll take this bx and slide it over to the other side by using subtraction. Now we have x that appears more than once. Well, here's the factoring thing that shows up again. So since x is common to both, we can say x is the greatest common factor, or GCF of this problem. We can pull it out. We just have that quantity cy minus b left, and we'll go ahead and just divide by that quantity on both sides, cy minus b, and then we'll be left with our final answer. Ay over cy minus b is what x equals. So what these are is literal equations where you're manipulating or moving equations around to get what you want. You should be able to solve for an equation and factor when a variable appears more than once. Thanks.